merge k sorted linked list and return it as one sorted list. Analyze and describe its complexity. Input, blah, 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 blah. Okay. Yeah, I mean, I think that's okay. I mean, I think this is like a very what you call it, like a textbook solution type thing, right? In the sense that and it's actually very practical, and we actually know this. Yeah, damn it, no spoilers. No, I was gonna get to that. It's fine. You only spoiled like a minute, but yeah, you're exactly right. That's essentially what I'm gonna end up doing. But um, but yeah, this is a textbook problem. I think this is also if you're very familiar with it, this is where you could kind of like, brag a little to your wow your interviewers, though I'm sure they have heard all the possibilities. The short answer is yeah, as Philip mentioned, uh, just use a heap. And kind of the relevance here is that at least to kind of real world programming is that you have quick sorts and you have merge sorts and all these stuff. But the problem is that this comes up in is that sometimes you can't store everything in memory. And well, if you can't store everything in memory, then you would use merge sort because so that you could kind of it's more memory efficient in that way because you could just combine them in different ways and you do one at a time and you don't need the entire list. You only need the top of the list, right? Assuming that they're already sorted in some way. So yeah, and then you could kind of like riff on that a little bit, but that's why I go. Okay, I will take a look at that next. But yeah, there's a there's a heap sort merge. Oops. Uh, heap queue that merge. Let me just take a look at what, what this merge stuff. Man, that is true. Heap queue does already have a merge to merge from multiple ones. I'm still going to code it just for fun out. I mean, I don't think it'll take that long, just because it is a standard problem, and I think maybe it's a little tricky to do it from because you have to play around because it is a linked list instead of like an array or something like that, right? But I guess you can make the linked list immutable if you want to write like a layer an interface for it or whatever. But I'm just going to do it quickly. Um, cool. Yeah, let me do that. Right. List and lists. That's the keyword. Oh, push keyword. Bucket of. Oh, L dot value and L. It could be L dot next. I think it's the same. Yeah, I generally will use my. So I mean, I think with you in an interview, definitely, um, yeah, definitely make sure that you communicate with your interviewers which one do you want to use. Because I mean, if they want you to code heap, then you have to code heap, right? There's no question about it. But yeah, too bad you do bottom up image. Uh, yeah, it depends. Yeah, but yeah, let me finish that thought for a second, which is that, but yeah, if they want you to implement heap, then it is what it is, right? But in general, I tend to, well, I asked them first that like, can I use heap, like a heap library, and then with, and generally the answer will be yes, and then that's the case, then you just do it. So yeah, so you could do bottom up merge, meaning I assume what you're meaning is that like you could take two lists, merge them, and then kind of merge them in like a tree like thing. I think in theory you could do it. I mean, there are a number of things you can do about it. I think the tricky part about that is that in general, maybe not in this Leetcode problem, in general is that you'll have trouble. I mean, you want to do things about fitting stuff in either memory or space or something like that. I think that's the general reason why, and you can actually do and probably is a very elementary exercise in complex analysis, right? Where in this case you have k lists, so you just do k or log k Oh yeah, it should be just n log k, right? Um, where n is the total amount of all the elements uh, in all the lists together. Where if you do them separately, there may be some log. No, it should be still log k ish. But you may get another log something factor. Yeah, but unless you mean like bubble them up or something like that. But yeah, I'm sorry, I wasn't sure what you meant. But if you mean just like bubbling up, then yeah. Okay, what am I doing? Uh, oh, oh, I have to return a sorted list. Oh, that's fine, right? Excuse me. Well, it's not hard. I just have to do it. Maybe I'm lazy. Maybe call it. Yeah, they didn't tell me to ban 1K, which some of the earlier problems suffers from. Wish they just go back and add them. I mean, how hard can it be? They have like so many users. Like if it's just semi-wiki style, I feel like they could have just added that. But I mean, I don't know. Not here to judge per se. Okay. I'm just trying to do this. Nope. This should only happen once. Otherwise, dot next is equal to node, and then current is equal to node. Okay, that's just processing it, and then now you push the next back in. So okay. I guess I just check it. I could clean this up a little bit, but let's just see if it works. Should be roughly right, maybe. The library names are a little weird for that one. I always forget. Yeah, there's one more. Oh, yeah, and this is a thing. Better than implementing myself. Okay. Let's just play around with a little bit more. Empty. That was pretty quick there. I always expect some typos, to be honest, but oh, I guess they have to be sorted within, right? Let's just do another one to it. I guess this part. Okay, fine. Like this. Okay, let's just move a little bit. Okay, cool. Yeah. So I mean, I think the literature on this one is pretty straightforward. I would even go as far as say, even though it's technically a hard, it's probably a little bit under. Like I would. I mean, I don't know about necessarily like the input output format because on an interview, they're not going to give you like a linked list per se like this. Maybe they do. I don't know. Actually, maybe I take that back. But in either case, like there'll be a variation of this problem. I feel like I don't know if I have. I feel like I've done something similar recently on, or like I've seen someone talk about seeing this problem recently, but maybe not on a linked list. But I mean, I think the idea is still like they want to just test your fundamentals, which is why you're going to have to understand like not just necessarily how to code this, but like some of the theories around this one, because this is a very textbook problem. So I definitely would expect to see others on it. But yeah, cool. So this would give you a link to this. Oh, right. But yeah, but I definitely recommend kind of practicing this one and making sure you not know just the coding, but also the theory around it. Just to kind of go over a little bit. Like I said, the complexity will be n times log k because each element gets pushed in a log k time. Um, and there's no extra space other than the heap, which is n log k, depending on how you find that. Well, actually, no, sorry. The heap will at most be k, so O of k extra space minus some like temporary stuff. But yeah, I think that's mostly right. Let me know if y'all have questions for that one. Uh, uh, this is a linked list. No, this is a linked list input though. Or do you mean like in the test case generator? I mean, it's these. I think this is very Leetcode specific. For better or for worse, this is just they will actually take this input and convert it into a linked list, even though it doesn't see it. I mean, it doesn't. For especially, I mean, this is okay in that like you can understand it, but actually it gets really annoying with trees because like you have to put in like random array things and it's trees and you're like, I don't know how. I mean, like I have a test case I want to put in, but I don't know how to make it to this format or something like that. But I think I saw somewhere on Reddit though that someone has a test case generator, so that does like lists and trees. So maybe I've got to look into that a little bit. But yeah, so this is definitely a very standard problem. So definitely recommend it and just understand the theory behind it as well. The fun